Hello children, welcome back. We nailed worksheet 12. Now let us begin with worksheet 12A for the next set of challenges. So here we begin with worksheet 12A. First question. A body is projected horizontally from the top of a hill. What is given, children? A hill was given. From the top of it, tower of a hill, a body is projected horizontally. With what velocity? U is given as 9.8 meter per second. Okay. So initial velocity of projection along the horizontal axis, let us take it as ux. The time elapsed before the vertical component of the velocity is twice the horizontal component. So this body may suppose it to fall down like this. Okay. So during its journey, at some point, it will be regaining some velocity, even though the horizontal velocity always remains constant, but the vertical velocity changes due to the effect of gravity. So here what is the condition given, children? It was given that the vertical velocity is twice the horizontal velocity. Children, from the formula V is equals to U plus AT, if you consider the motion along a horizontal axis, then V is replaced with Vx, which is equals to Ux plus Ax into T. As long as the body is moving in the horizontal direction, this Vx always remains constant as Ux. Why? Because the acceleration during the horizontal motion gets vanished. So this will be 0. Hence, Vx is always equals to Ux. Whereas, if you try to find out the velocity attained during its vertical motion, then it is given by Vy is equals to Uy plus Ay into T. So this Vy can be written as, so whenever the body is falling downwards, okay, moving in the vertical direction, then the initial velocity is taken as 0. Okay, it is considered as a freely falling body. So Uy is taken as 0. Acceleration along downward direction is taken as G into T. So we know that the value of Vy is equals to Gt, and whereas Vx is equals to Ux. Substituting those values in the above condition, so how much are we getting, children? So instead of Vy, let us replace it with Gt, and instead of Vx, let us replace it with Ux. Clear? So now substituting the values, we can find the value of, you are asked to find the time elapsed. Time elapsed means T. So T can be found as 2 times of Ux by G. So what is the value of Ux, children? Given as 9.8. So 2 into 9.8 upon the value of G must be taken as 9.8 itself. So now this 9.8 and 9.8 gets cancelled. So now you are left with 2. Hence, the time elapsed such that the vertical velocity becomes twice of the horizontal velocity, will be 2 seconds. Is that clear, children? Well, moving to the next question. Question number 2. A particle projected horizontally from the top of a table. So for this we need to consider something like this. So what is given, children? A particle is projected horizontally from the top of a table, touches the ground at a distance D from the edge of a table. So what is given? From the edge of a table, this is the edge of a table, okay, from the edge of a table, this touches the ground at a distance D. If h is the height of the table, what is given? The height of the table is given as h. Then the velocity of the projection is, so this must be the velocity of projection. Let us suppose it as some u. So you are asked to find this velocity of projection. Is that clear, children? Well, for this, we know that from the equation S is equals to ut plus half at square along the horizontal direction, it can be written as Sx is equals to ux into t plus half ax into t square. As long as the body is moving in the horizontal direction, this ax will be 0, hence this term will be vanished. Hence we have Sx is equals to Ux into T. Okay, so considering those values, we have, what is the condition given, children? Sx is equals to Ux into T. Well, the value of Sx is nothing but the horizontal distance covered by the body. That is nothing but the range of the projectile. So whether it is the range or the horizontal distance traveled by the body, its value is given as D. So substituting the above value D equals to Ux, we have considered Ux as some U into, as the body is falling downwards, the time to travel that particular distance is taken as root over 2h by g. Time of descent is taken as root over 2h by g. So you're asked to find the value of U. Hence, solving for that and bringing this term to the left side, this will become reciprocal. So hence we have, keeping the U the other side, you will get D into this. After coming to left side will become reciprocal. That means D times of root over g by 2h. Hence the value of U is found to be D times of root over g by 2h. Hence the correct option must be option number 4. Okay children, D times of root over g by 2h. Next, a body is thrown horizontally from the top of a tower 40 meters height. So what is given? A tower of height 40 meters was given. From this top of the tower, a body was thrown, okay, with some initial velocity. Let us suppose it has Ux, and strikes the ground at an angle of 45 degrees. It was given that after reaching the ground, it reaches the ground at an angle of 45 degrees with the horizontal, like this. It reaches the ground at an angle of 45 degrees, some velocity. We know that this velocity vector is resolved into two components, horizontal component and vertical component. One is Vx, the other is Vy. If you observe this figure carefully, 45 degrees, this is Vx and this is Vy. From the figure, we can consider that tan alpha equals to opposite by adjacent side. So what is the value of tan alpha, children? From the figure, we can conclude tan alpha as Vy by Vx. But what is the angle was given? 45 degrees. So from this we have tan 45 degrees is equals to Vy by Vx. But tan 45 is taken as 1. Hence, substituting the values, 1 is equals to Vy by Vx, or instead of Vy, we can also replace it with Vx. So, wherever we get Vy, we can replace it with Vx. So now moving to the numerical. This is only the given condition. So to find out the numerical, the speed with which it hits the ground is, yes. So let us check out the vertical motion. We know that the horizontal velocity always remains constant. That is Vx is always equals to Ux because there is no effect of gravity. So what changes will be brought means only in the direction of vertical motion. From the formula V is equals to U plus AT. V is equals to U plus AT, we can say that Vy is equals to Uy plus Ay into T. Okay, during the vertical motion, the first kinematic equation is given as Vy is equals to Uy plus Ay into T. So this Vy can be written as, it is an example of a freely falling body. So during the freely falling body, Uy initial velocity along vertical motion is taken as 0. So this is 0. Acceleration along y-axis is g into t. Okay, but what is the value of Vy, children? It can be replaced with Vx is equals to g. Time taken to reach the ground in terms of height can be written as time of descent, that is 2h by g. So taking the value of g inside, will get Vx is equals to g taking inside will get 2g square h. This g taken inside will become g square into h, and this g and that other g will get cancelled. So you are left with root over 2g h. So Vx is nothing but equals to Ux, and the value of Ux or Vx is given by root over 2gh. So Vx can also be replaced with Ux, velocity of throw, because the horizontal velocity always remains constant. This can be written as root over 2 into value of g, let us take it as 9.8 into height was given as 40 meters. Substituting in the above equation, we have root over 2 into 9.8 into this 0, if it is multiplied means it will become 98 and the leftover number is 4. Okay, so taking the square root of the above equation, we have Ux is equals to root over 2 into 98 can be written as 2 into 49 into 4. Yes, taking the square root, children, 2 into 2, twice, 2 times it has been repeated. Root over 2 into 2 is 2. Root over 2 into 2 is 2, and root over 49 is 7, and root over 4 is 2. Okay, so the product of this is 2 7s 14, 14 2s 28. Hence, the velocity of projection is nothing but 28 meter per second. Hence, the correct option must be option number 3, that is 28 meter per second. Okay, well, moving to the next question. Question number 4. A bullet shot from a rifle at 25 meter range strikes the target at a point 4.9 centimeters. So, bullet is fired from the rifle. A gun is there, bullet is been shot, and that is been hitting, which the barrel is pointing horizontally. Then muzzle velocity of the bullet is the initial velocity you are asked to find out. Okay, children. So for this, what distance? The range is given as 25 meters, and the point strikes the target at a point 4.9 centimeters below. Below means that height difference. Okay. So this is the barrel from which a bullet is being released. This bullet reaches a target, and this target is at a height. How much height lowered, ma? It is given as this height is 4.9 centimeters. How much is that? 4.9 centimeters below that, at which the barrel is pointing. The muzzle velocity of the bullet is, and the bullet shot from a rifle 25 meter range strikes, this is the target, and the range is given as 25 meters. This is in meters and this is in centimeters. Height is given in 4.9 centimeters, whereas range is given as 25 meters. Simple. You are asked to find the muzzle velocity. So what is the relation between range and height, children? As we have already discussed, from the formula R is equals to UT, because no gravity. Sx is equals to Ux into T plus half Ax into T square. Ax is 0. So Sx is equals to Ux into T. Sx is nothing, the horizontal distance taken as range is equals to UT. Okay. So what is the range given, children? 25 meters is equals to U into T. Instead of T, I can replace it with 2h by G. So you're asked to find the muzzle velocity. From this, the value of U can be written as 25 into this, after bringing the other side, will become G by 2h. So substituting all the values, we will get the value of U as 25 into root over value of G must be taken as 9.8 upon H is given by 4.9 centimeters. If you convert 4.9 centimeters into meters, it must be 4.9 into 10 power minus 2 meters. So solving this, we will get the value of U as 25 into root over 9.8, multiplying and dividing with 10, both numerator and denominator. 9.8 into 10 will become 98. 4.9 into 10 will become 49 into this 10 square, 10 power minus 2. If it goes upward means then it will become 100. 1 by 100. Okay. So 10 power minus 2. This is carried up means it will become 100. Is that clear, children? Well, based on that, let us try to find out the muzzle velocity. Okay. Somewhere, yeah. So G is taken as Here 25, G is taken as 9.8, H is taken as 4.9 centimeter. So here the 2 is missing. Let me substitute the 2 here, children. Okay, by 2. Then how much it will be, children? This will be 2 goes 49 times. This 49 and 49 will get cancelled. Then you are left with U is equals to 25 into root over 100 is 10. Hence, the value of U is found to be 250 meter per second. The value of U is found to be 250 meter per second. So, option number 1 is true. Okay. Well, moving to the next question. Question number 5. A body is projected horizontally from certain height. After 2 seconds, its direction of motion makes 30 degrees to the horizontal. Then its initial velocity is. So, what is the given data, children? Again, the body is projected horizontally and the height, certain height is given. Time was given as 2 seconds. Direction angle was also given as 30 degrees. Simply you are asked to find out the initial velocity. Okay. So to start with, let us try to find out the value of tan alpha. We know the formula for tan alpha as we have discussed in the earlier case. Tan alpha can be written as Vy by Vx, and now the value of alpha is given as tan 30 degrees is equals to Vy by Vx. Okay, and we know the value of Vy. Tan 30 can be written as 1 by root 3. Vy can be written as gt, and the mesial velocity, final horizontal velocity always remains constant, whether it is ux or vx or ux, or let us simply take it as that velocity as some u. Okay, so we know that vx is equals to ux. Let us suppose this ux as some u. You are asked to find this initial velocity. So, u is found to be gt times of root 3. So, what is the time given? So, time is given to be 2 seconds. So, substituting the above values, we have u is equals to g into time is taken as 2 and here root 3. So, the correct option is g times of 2 root 3, or it can also be written as, rearranging the terms, it can be written as 2 root 3 g. Hence, the velocity is found to be 2 root 3 g. Okay.